All right, guys, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom with me, Coach Gu. This is Unit 9, Notes number 4. Today we're going to be doing Intro to Logarithms. So write this down, guys. If you want to title your notes, write it down. Otherwise, it's not going to be there. All right. Okay, after you've written that down, you might want to write this down. I want you guys to take a second and right here, what is x? I've given you 4 equations right here. 2 to the x equals 4, 2 to the x equals 32, 10 to the x equals 1,000, and 4 to the x equals 1 over 16. So can you tell me what x is for each of these? What would x be on the very first one? 2, that's right. Why would it be 2 over here? Because 2 squared is 4. That's right. X equals 2 right there. Okay, what about on the next one then? What would x have to be to get 32? 3? 2 times 2 times 2 is 8. So it's not 3. 2 times 2 times 2 times 2 is 16.
So 5.
5, that's right. So x equals 5. And why is that? Because 2. Yeah, you can write whatever you want. 2 times 2 times 2 times 2 times 2 is 32. That's why x equals 5 there. You need an exponent of 5 to get that 2 to a 32. What about on that third one? 10 to the x equals 1,000. What would x have to be there? What would it be? 4 would be 10,000. So the general rule with tens, remember, is however many zeros you see in the final product, that's the exponent. So 3, that's right. X equals 3. Now what about that last one? 4 to the x equals 1 over 16. Negative 4 is not right, but it's on the right track. And what did you say? Negative 2. That's right. It's negative 2. How did you get negative 2, Oliver? How did you get negative 2?
Because I know that negative turns it into a fraction.
Right?
And then 4 squared is 16.
Exactly. That's perfect. Because 4 squared with a positive 2, that equals 16. Said he knows that a negative exponent would turn into a fraction. So yes, the 4 to the negative 2 would bring it to 1 over 16. All right. Okay, so this is a good transition into what we're doing today. So what you just told me. Okay, do you know the answer to this? What is the log base 2 of 4? What's that? Do you know the answer to that? Yeah, so you probably don't know by looking at that first glance. However, no, you don't need a calculator. You already told me the answer for that. The answer is 2. When you solve this up here, 2 to the x equals 4, and you told me what x equals, that's the same thing as me asking you, what is log base 2 of 4? The answer was 2. So, can you tell me what the log base 2 of 32 is? Yeah, you already told me what it was. It was 5. That's right there. So the same thing is going to be if I ask you what is the log base 10 of 1,000? 3. Yeah, you gave me the answer already. And lastly, write this down. Log base 4 of 1 over 16. What would that be? That's negative 2. So without you even knowing that you were doing this, you're able to find what log values are. That's what you're doing when you're finding x. All right, so let's make sure that we're not illiterate here and make sure we know how to read this kind of thing. So if I put log with the b down here and an a right here equals x, how would you read this statement? You're going to say log base b, whatever b is, of a is x. Okay, so that's how you read this kind of statement, all right? Log base b of a is x. So could you tell me how to read this third one over here with the 10 and the 1,000? Log base 10. Log base 10 of 1,000 is 3. That's right. That's how you read it, okay? Okay, so can anybody guess what exactly the log means then? Like what is a log? Like I told you up here, when you were finding x right here, you were telling me what the logs were. So what is a log? What were you finding up here? The exponent that what? It's not just any exponent, right? I couldn't just put a random number in there and say that's right.
The exponent that equals 4.
The exponent that, I think I know what you're saying, but it's not coming out the exact clear way. So you're pretty much right. You're looking for the exponent that brings this base to equal that number. Okay? So what the log means, it means the exponent you raise b by to get a. All right, look over here on this first example, right? 2 raised to what gives you 4? The answer was 2, right? And that's what it says right here. The log base 2. So what would you raise this 2 right here to get 4? The answer was 2. What do you raise this 2 over here to get 32? 5, right. What are you going to raise 10 by to get 1,000? 3. That's what the logarithm is, okay? All right, so let me show you this then. Is everyone have this down? Who needs this? Okay. So, oh, what the heck? Wrong button. So I just showed you that pretty much 2 to the x equals 4 is the same thing as saying log base 2 of 4 equals x. So just now I told you this is the same thing, right? Me asking you what is x when 2 to the x equals 4 is the same thing as me asking you what is the log base 2 of 4. That's the same idea, right? But some people like to see this algebraically. Some people would prefer to see the actual steps instead of just somehow getting from one step to the other, right? Because this is just taking my word for it right here. But there's actually an algebraic process that is actually happening between these two steps. So, after I finish writing this down, why did I put a? So we see 4. 4. Alright, so how do I get from one step to the next? I will show you here. Because some people prefer to see the algebraic way, okay? That way they can follow the process every single time. Okay, so notice right there we got x by itself, right? It says log base 2 of 4 equals x. X is by itself, which means if we're trying to go from here, 2 to the x equals 4, into there, we're trying to solve for x, right? We're trying to get x by itself. Somebody out there? Yes. All right, and you guys have learned about different types of inverses already, even if you don't call them inverses. For example, if I told you x plus 2, how do you get x by itself? You subtract 2, right? That cancels it out. Okay, what about 4 times x? How do I get x by itself? Divide by 4. Those are inverses. They cancel each other out, right? So you can get x by itself. But look at this. We have x. Now the problem right here is x is in the exponent spot, right? We don't want it to be in the exponent spot. We want to bring it down to just be in the normal number spot, right? But how can I do that? I would have to cancel out this base of 2, right? You see how this x is the exponent of my base that is 2? So I want to cancel this base out. And how would you do that? Up until today, unless you took other classes, you didn't know the operation to cancel out a base, right? You didn't know the inverse of a base. So what you're going to do here is you're going to take the log of the base. So what is the base right there that you're trying to get rid of? 2. So you're going to introduce to both sides, you're going to introduce log base of 2. That's going to get rid of the base 2. So we introduce this there, log base 2, 2 to the x. Now you see how I just out of nowhere, I pulled out this log base of 2, right? Because I wanted to use it just to get rid of something, right? So whatever you do to one side of the equation, what do you need to do to the other? You got to do the same thing, right? So what do you think I should write here? Over here I just put a log base 2 out of nowhere. What should I write here? Yes. They're showing you how to go from step to step.
Yeah, I would just make cover right then.
Right. You also have to put log base 2. But then the right side is going to be log base 2 of what? Of 4. That's right. So notice the 2 to the x and the 4, they're still there. All we did was introduce the log base 2 to both sides, right? And what was the point of doing that? Why do we do that? Because that's going to get rid of this base of 2 right there. So that just cancels out right here. That base 2 and the log base 2 cancel out. And that's going to bring our exponent down. That's going to bring the x down to normal number. So now it's going to be x equals, what's on the right side? Of? Yeah, make sure you say this whole thing. Log base 2 of 4. That's right. And then now look, isn't that originally what I said it equals? This is the mathematical step that happens in between the 2 to the x equals 4, turning into log base 2 of 4 equals x. You see I have the x, I got a log base 2 of 4. Okay? Some people may not remember, how to go from one to the other, but this is going to be a process you can always do. So seeing this, can you guys tell me then, what is the 10 to the x equals 1,000. Can you tell me what I would do to get that into a logarithmic form like I just did? Log base 10 on what?
That side. And log base 10 of 1,000 on the other.
Right, log base 10 of 1,000 on the other side. So Trey just introduced the log base 10 on both sides. Why did you pick base of 10 and not base of 2 like the other problem? What? Because you're trying to what? Why are you whispering? Yeah, you're right though. Yeah, because you're trying to get rid of the base that is 10. That's right. Okay, so what's going to happen on the left side over here? Cancel out, which leaves you with what? Right, the x is going to come down into a whole number, into a real number, equals? Right, log base 10 of 1,000. And that's all I asked you to do. Just go from one form to another. All right, so now we're going to jump into some different examples of problems that you will see dealing with logarithms. So, why do I keep pressing X? Ah. Example set number 1. Yeah, I know. Some people might still be writing this down. All right, so the first examples we're going to do is change from exponential form to logarithmic form, okay? Exponential form is where there's an exponent, obviously. That's why it's called exponential. There's an exponent. So let's do 2 to the 5th equals 32. This is the exponential form, right? Because, look, you see the exponent, 2 to the 5th, right? So I just want to change this into a logarithmic form. You're not solving anything. You're just changing the form. So what would I do here? We just did this. Same idea. What do I do? Log base 2 to the 5th. On the right side is going to be? Right, log base 2 of 32. All right, what happens on this left side over here? This is gone, and that brings the 5 down, right? It's not an exponent anymore. Now it's just a number. Equals? That's right, log base 2 of 32. And that's all I was asking you to do. Go from exponential form to logarithmic form. That is this. Let's do one more example like this. We're going to do 4 to the negative 2 equals 1 over 16. So how would I change this into a logarithmic form? What do I do? Right, log base 4 of 4 to the negative 2. And then? That's right, log base 4 of 1 over 16. Which results in what? That's right, negative 2 equals log base 4 of 1 over 16, and that's your answer. That's it. What? No. All right, so you guys have done this, showing the mathematical steps, right, to get from your beginning to the end right there. But some people might be able to see a pattern here, or maybe just understand what the log is even saying, and they will be able to get the answer immediately without having to show this step right here. So, for example, if I told you 3 to the 5th equals 243, could you, without even showing that mathematical step, could you just get the answer right away in logarithmic form? Take a guess. Let's see if you can get it. What would the logarithmic form be? This 3 to the 5th equals 243. Get this into logarithmic form without doing the step in between. Can you?
Yeah.
What is it? 5?
5 equals log base 3.
Right?
2.3.
That's right. And you just got the answer. That's it. Let's make sure you didn't get lucky. I'm going to do one more then. Let's go 6 to the negative 1 equals 1 over 6. Can you change this into logarithmic form without doing the mathematical steps in between? Negative 1,
Log base
right, equals log base 6 of 1 over 6. That's right. And that's it. You got the answer. So some people can see a pattern, some people can understand what the log is saying and go between the forms, and some people need to use the algebraic way, right? Doesn't matter which way you do, all three of these are anyways correct as long as you're getting that same answer, right? So I showed you both of these ways so that you can choose whatever way is comfortable for you. All right, so feel free to use either way. And let's go on to the next type of example. Of course, if we went from... You want another piece of paper? Yeah, come get some more paper then. All right, so if you're able to go from exponential to logarithmic, then of course you should be able to go the other way around as well. So now we're going to go from example 2, we're going to go change to exponential. All right, so we're going to change to exponential form. I'm going to give you a logarithmic form, and I want you to change it into an exponential form. So for example, log base 9 of 81 equals 2. Bless you. Can you change this into an exponential form? What is it? 9 squared equals 81. That's the answer. Good job. That's it. Okay. What about, yes, log base 5 of 125 equals 3.
5 cubed.
That's right, 5 cubed. That is correct. Five cubed equals 125. Right. Some people understand that, these logs, what it's saying is that, 5 raised to the 3 gives you equals 125. That's what it is. Exactly. However, some people might be wondering, how do you actually go from one step to another? How does that, what happens there instead of just getting an answer out of nowhere? So, because you guys are just getting this by sense, right? But there is something happening mathematically in between these two steps. So, on this last example that we're going to do for this type of problem, first I want you to just tell me the answer. What's the answer to this? How am I going to change that to exponential form? Log base 4 of 1 over 16 equals negative 2. That's right. So that would be your final answer in exponential form, right? 4 to the negative 2 equals 1 over 16. Now, how do we even get that, though? What are you doing in between there that actually takes you from one step to the next? So, I'm going to show you. Look at our original. We have log base 4 of 116, right? And in the final answer, you just have 1 over 16. So what did you get rid of there? Look at, yeah, that's right. So the original, right, we have log base 4 of 1 over 16, right? And the final answer that you gave me is just 1 over 16. So what did you get rid of? And Trey said we got rid of the log, right? So how do we get rid of the log? Now remember, the log we use to get rid of a base. And so we can go the other way around. We can use a base to get rid of a log. So we can use, what is the base on this log? 4. So I can introduce a base of 4. So 4 is going to be my base, right? And this log 4 of 116, that's going to become my exponent. Like this. Equals, and because I introduced that base of 4 on the left side, what do I have to do on the right side? 4 raised to the? There's no log here. What? Negative 2, that's right. You see, it's the exact same thing. Whatever you do to one side, you got to do to the other side. But the numbers don't change, though. All right? Now, what happens here? The 4 log base of 4, that's going to cancel out right there. And then that brings this 1 over 16 down. That's how you get this. And then what's on the right side here? That's the 4 to the negative 2. What? No, I'm just showing you what happens because some people are curious. How do you even go from one step to another? But yeah, anyways, that's actually what's happening there, though. So that is it for that. All right, so the next example right here, example number 3. Yes, we do. 2 more. You can get more paper. All right, so for this next example, we're going to be, you're going to write it in exponential form, and then you're going to solve for x. So these are the first ones we actually have to solve. The other ones we just rewrote problems, right? Now you're actually going to have to solve for it. So if I gave you log base 3, log base 3 of 81 equals x. First, I want you to rewrite that in exponential form. 3 to the what? Right, 3 to the x equals 81. That's exponential form. And now you have to solve for x. So what is x going to be? 3? So 3 times 3 is 9. Times 3 is 27. So it's not 3. 4. That's our x is going to be 4. Because 3 times 3 times 3 times 3, that's 4 times, right? Equals 81. So there's your answer. Boom. What about log base 7 of x equals 2? Notice the x is in a different spot, so don't assume the x is going to be the exponent. Just look at the original equation and then change it into exponential form. 7 squared. Oops. That's right, 7 squared equals x. 7 squared equals, wait, hang on a second. 7 squared equals x, and then you said x equals what?
49.
49, right, because 7 squared equals x, 7 squared is 49. There you go. Last one, log base 4 of x equals negative 2. How would you rewrite that one into exponential form? 4 right to the negative 2 equals? That's right. What did you say? Exactly. Wow, perfect. X equals 1 over 16. Nice. How did you get the 1 over 16 anyways? What? Alright, that's a terrible explanation. Yeah, 4 to the positive 2 is 16. So 4 to the negative 2 is going to be 1 over 16. Alright. Puts it over in fraction form. So that is this type of example where you're changing to exponential form and solving for x. Which leads us into the last type of example. Almost pressed that again. Example 4. All this is going to say is evaluate. And you got to give the answer. All it's going to say is evaluate. So for example, you're going to see something like this. Log base 5 of 25. What is that? Yeah. What's the answer to this? Yeah. Okay, so yeah, Edgar's already given us the answer. He said it's 2. The answer is 2. That's right. Yeah, so they're only going to give you log base something of something. You got to give the answer. Log base 5 of 25 equals, it's 2. Right? Because 5 needs to be raised to what to get 25? 2, exactly. All right, but now the problem with this kind of question is some people have a hard time visualizing what you're actually trying to find, right? So what you can do is if you have this, look, log base 4 of 64. What? Log base 4 of 64. So let's say, you can't really visualize what you're supposed to be finding here. So you know that it's always supposed to be equal something, right? So if you have trouble just seeing what the answer is right away here, you can go ahead and write equals, and you don't know what it equals. You're trying to find that out, right? So you put equals x. Then change this to exponential form. What would this be in exponential form? Four to the x equals 64. And now doing it this way, you can really visualize what you're trying to find, right? So now you can see you're trying to find the exponent. And so what would the answer be? 4 times 4 is 16 times 4 is 64. Times 4 again is 256. That's 3. And so in this case, your answer is 3. All right, let me give you a more complicated one that you will see. What is log base 64 of 8? Not sure exactly yet. We'll see. On the homework and stuff, though, and the quizzes, though, it tells you to evaluate with no calculator. So you need to be able to do it without a calculator. On these ones, though, look, you can just check yourself like by actually doing the multiplication. Like this one, if you didn't know it's 3 right, you could do this. 4 times 4, what's that? 16. Then, okay, so it's not 2, right?
Yeah.
So let me check 3. All I have to do is multiply by 4 again. 4, 2, 1, 64. Did I get my answer?
Yeah.
That was 3 times, right? Because I just went from 2 and I added 1 more.
Yeah.
So you can just...
I was just, like, figuring like big numbers.
It shouldn't be big enough to where... If it says without a calculator, it'll be small enough to where you can do it without a calculator. Okay, but how would you do this one? Log base 64 of 8.
64 times 64 times 64 times 64.
Whoa, no. We're trying to find what this equals.
Oh, I don't know.
This one, let's write it into exponential form. How would we write this one into exponential form right here?
64 times 64 times.
No, 64 to the x, right?
Oh, that. That's what you talked about.
You got to make sure you understand the vocabulary, because when you're doing exams and things like that, right, it's just going to give you the instructions. It's not going to give you an example and show you what it looks like. You need to know what the instructions are asking you to do. 64 to the x equals 8. How does that work? We're going from a bigger number to a smaller number. Negative is going to make it into a fraction, which is not what we're doing. A decimal, that's actually right, but it's not going to be necessarily a decimal. It's going to be a fraction. We learned this in Unit 8.5. I don't know if you remember this, but we learned this in Unit 8.5. Look at this. How do I get 64 to be 8? What is 8 in relation to 64? It's the square root. That's right. 8 is the square root. Okay. 8 is the square root of 64. You can write roots as fraction exponents. Remember this? We did this like in Unit 8.5. But you can write roots as fractions in exponents. How do we do that? Remember, the power on the inside is the top number, the numerator on the fraction. Yeah, 1 over 2. That's the answer. How did you get that? What's the index on this square root? The index on the square root. So that means it's what? 2, remember? Square root is 2.
Oh, yeah. I'm sorry.
It's a 2. So that tells you the bottom number of the fraction. So it's going to be 1 over 2. If it was cube root, what would it be? 1 over 3, that's right. If it was the fourth root, it would be 1 over 4, exactly. That's how you change the roots into fraction exponents, okay?
So 1/2's the answer?
Yeah, the 1/2 is the answer here. Because 64 raised to the 1/2 gives you 8. All right, and then one last note that you need to make. Watch this. Log of 100. Can you tell me the answer to this? Log of 100? Why do you think it's 10? 10 times 10 is 100, but what looks different about this that I just wrote than everything else? There's no base. That's right. And so that's what I want you to notice here. On this one, you see there's no base written, right? So, in this case, this is called a common log. It is called a common log. That's right. You know how on the square root symbol, right? We always just write this, right? This is the square root symbol, right? Or the principal square root symbols. So, but there's an index here, but I didn't write it, right? What's the index? 2, right? That's the same idea as when you don't write a base. There's an understood number. It's not 1, but it's a certain number, and I'm about to tell you. It is, when the base is not written, the base is 10. It is 10. So anytime they don't write the base, you can just write a 10 in there because that's the same thing. So this one right here that I just asked you, log of 100, what's the base actually here? 10, which means what's the answer going to be? 2. What do I raise 10 to get 100? 2. All right? So be careful for that. Whenever you don't see anything written on the base, that means the base is 10. Okay?
No matter what the number is?
Yeah, no matter what the number is, doesn't matter.
Okay.
When they don't write a log, there's no base here, then it's just 10. You just put the 10 there. And that's going to be it, guys. That will be everything. So until next time.